How does precipitation lead to water infiltration? Have you ever wondered what happens to rainwater after it falls to the ground? The journey of precipitation is fascinating and plays a vital role in our environment. Precipitation refers to water that falls from the atmosphere to the Earth's surface in forms like rain, snow, sleet, or hail. Once this water reaches the ground, it can either run off or enter the soil through a process called infiltration. Infiltration is essential because it allows water to move into the soil, replenishing moisture and groundwater supplies. The connection between precipitation and infiltration starts as the water lands on the soil surface. For infiltration to happen, the soil must be porous, meaning it has spaces between particles that allow water to pass through. When rain or melted snow hits such soil, the water seeps down through these pores, moving deeper into the ground. Once the water begins to move downward, this process is known as percolation. It continues until the water reaches the saturated zone, where all pores are filled with water, which we call the water table. Several factors influence how precipitation leads to infiltration. First, the type of precipitation matters. Rain usually infiltrates faster than snow or sleet because liquid water can easily enter soil pores. Snow must first melt before it can infiltrate. Next, the amount and intensity of precipitation play a role. Light to moderate rainfall allows more water to infiltrate since the soil can absorb it gradually. However, heavy rainfall may exceed the soil's capacity, causing excess water to run off instead. Soil characteristics are also important. Soils with larger pore spaces, like sandy soils, have higher infiltration rates. In contrast, clay soils with smaller pores infiltrate water more slowly. Interestingly, dry clay soils may develop cracks, which can temporarily increase infiltration. Soil compaction reduces pore space and lowers the ability to absorb water. Another factor is the soil moisture content. When soil is dry, infiltration rates are higher at first. As the soil becomes saturated, infiltration slows down until it cannot absorb any more water, leading to runoff. Surface conditions also affect infiltration. Vegetation cover, organic matter, and soil structure help protect the soil surface and maintain pore spaces. In practical terms, the process of infiltration following precipitation is essential for recharging groundwater, supporting plant growth, and maintaining the balance of the water cycle. It reduces surface runoff, which can lead to erosion and flooding, and helps sustain streams and rivers during dry periods by slowly releasing groundwater. In essence, precipitation delivers water to the soil surface, and infiltration allows this water to penetrate into the ground. The type and amount of precipitation, soil properties, and surface conditions all play a role in this process. Understanding how precipitation leads to infiltration is key to appreciating the connection between atmospheric water and the water we relying on underground.